Hello friends, I am Jyotirvid Pawan Kumar. Welcome to my workbench. In this video, I am going to describe how you can make very interesting electronic item or electronic gadget, which is this one. This is the finished one, which I am going to describe how you can make. And I am using this housing for the circuit from a discarded CFL. This is the top portion of a CFL, and this is female USB socket which I have obtained from a discarded USB cable, and I have fixed this on top of it with the epoxy M seal. And here's the switch which I have fitted here, on off switch, and inside the complete circuit, wired up circuit. Now the beautiful thing is that the whole thing runs from single 1.5 volt dry cell, and with this one, this gadget or item, you can run flexible USB light which usually runs at 5 volts. This is used to light up your laptop also. So this is usually run at 5 volt, but with this gadget you can run this, you can light it up with just one single 1.5 volt DC battery. And also you can run a fan, USB fan, which is easily available these days in the market. So before I describe how to make this interesting item, let me tell you about the circuit diagram. This is the circuit diagram, and I have already explained the circuit, working of the circuit, in some other video, and I have already described how to construct the circuit, but in this one I will explain it again. So this is the circuit diagram. This is called blocking oscillator or switching circuit. Blocking oscillator. It oscillates at around 40 kilohertz frequency, and it converts 1.5 volt DC into 4 to 5 volt pulses, spikes at this point. So you can run anything, LED or fan, USB fan, by connecting here. This resistor is optional, just to limit the current, but I am not using it. Okay, but you can use a low value resistor, about 33 ohm, but I am not using it because this will limit the current. So I want to run the LED or the fan at full speed, so I am not using this resistor. Now this flyback transformer I will just explain how to make, but I am using the core, ferrite core, for this transformer from a discarded CFL. This transistor is also I have removed from a discarded CFL, and this 1K resistor, to give bias to the base of this transistor, you need to buy it from the market. This 1K value is not available in the CFLs, and this 1.5 volt DC battery, of course, you have to buy. Now, in order to make this, no, first of all, let me tell you that when you have a discarded fused CFL which is out of warranty and it is no longer useful, then you can open it up. You can place this screwdriver and just hammer it a little bit, and then you can open it up easily, but be careful, this glass portion, if it breaks, then you can hurt yourself, but if you're careful, then open it up, and first of all remove the glass side by cutting the 4 wires, and just put it away. Now we have the housing which we are going to use to house our circuit, and you have to cut the wires connecting to this PCB, but cut right from the end which is soldered on the PCB, because you need these wires, right? Let the wires be of this length. Complete. Another thing is that CFLs come in different wattages, different sizes. So this housing is no good. It will not accommodate all the components, including the battery. So I am using this one, and this CFL is 20 watt. 18 watt or 20 watt CFL I think will be sufficient for this project. So you can take this. This is the housing we are going to use, and let these wires be there because you're going to connect the output of the circuit, which will be available here, and then we can fix the USB female right here, and we can then fix it with a epoxy so that it stays there. Now once you have removed the housing, now from this PCB of the CFL which we have just opened up, you need to remove this ferrite core and a transistor. Now in high voltage CFLs, the transistor is of this type. It's a power transistor. But in low power CFLs like this, the transistor is in TO92 package. It is smaller, this one. So both these will work. And I have already explained in a video that for these two transistors, this transistor which is in the TO92 package, you can note down that when you keep this transistor in a way that the flat portion is towards you, then the leads are, first lead is base, then collector, then emitter. And for this transistor, which you will get in a high power CFL, one side is metallic, other side is plain. So keep the plain side towards you, then the lead outs are base, collector, emitter, same as for the other transistor. So both these transistors can be used in the circuit. I have tried both these. Now in the circuit diagram, probably you know, this is the base, this is the collector, which will go to one end of the flyback transformer, and this is emitter, which will go to the negative side of the supply and negative to the output. Remove this flyback transformer from here and remove the wires, and you only need this ferrite core, toroidal core. And for winding this flyback transformer, you need a copper wire. This is insulated copper wire, 30 gauge or 28 gauge you can take, and you need a piece about 44 centimeters long. Then fold it in the middle so that each side is about 22 centimeters. Then take this ferrite core and keep about 2-3 centimeters here, and then you wind around this core tightly, both the wires together, and in all you wind about 9 to 10 turns. So this is the finished one I have already made, just to show you. It looks like this. So one side which is still connected, I haven't cut it, and the other side has two ends. So this is the beginning, this is the end. Now it is important to run this circuit. I'll show you on the circuit diagram. This is one coil, this is the second coil, and this is the end which is joined together. Okay, the other ends are free. Now we need to connect. This is the beginning, this is the end. But these red dots show that you connect the wires in such a way that this, for this L1 coil, this is the beginning end, and for L2 this is the end side, reverse. This is necessary in order to give positive feedback in this oscillatory circuit. Now for that, what you do is you cut this portion which is still joined, and then cut all the wires equal size. Then you have to scrape the ends of each wire because this copper wire is insulated, so you need to scrape the ends like this. Scrape it well with a knife carefully, and underneath you will get shining copper color. So if you don't scrape it, then you won't be able to solder it. When you scrape each wire, it will look like this, shining copper wire. Okay. Now it is very important, just watch carefully. This is the beginning side of both the wires, this is the end side. Now we have to differentiate which is which coil. Now just with this multimeter, first of all let me scrape all the ends. Now put the multimeter on continuity testing point, which means when you connect both these ends you will get a sound, a buzzer sound. Now I connect this is the beginning side, this is the end side. Connect one probe to one wire on the beginning and connect to the other side on each side, each cable, each wire, and I get continuity for this. That means this wire is the same. Okay, so what I have to do is take one end of this and connect it at the end, from the end side, the one wire from the second wire, not the same. So this becomes the joint part which in the circuit will go there to the positive side, positive of the battery, and the other two ends, one end will, doesn't matter which one end will go to the 1K resistor, through 1K resistor to the base of the transistor, and the second will go to the collector and the output to the whatever you want to run with this circuit. So before connecting to the circuit, you have to tin the wire ends so that it is easy to solder them. You can tin with the solder like this. So properly tin all the ends. So your flyback transformer is ready. Now you will need a switch which is push fit switch. You can obtain on off switch, you can obtain easily from a component shop. It is very cheap. You don't need to fix it. This is just push fit. But for this you will need to make a slot on the CFL housing. Now I am using CFL housing, this one from 22 watt. The smaller one, as I have already told you, is not good enough. So I will show you on this piece how to make slot for the switch. So take the switch, and on the CFL housing somewhere here, mark the size of the slot you need as per the switch. So it will be about this size. Okay, then you need a small hacksaw to carefully this side and this side, and then with the soldering iron you can mark this side carefully. On the four sides you can mark with the soldering iron, and then it will take some time, and you can use this knife and you can very carefully be careful while using such a knife. You can cut it out. It will take some time, but you can cut out like I already done on this piece which I have already made. So after making slot for the switch, you can push with the switch there, and now you can construct as per the circuit diagram. You can construct the circuit, and in another video I have explained that you can construct this circuit on a piece of general purpose PCB. This is general purpose PCBs come in different types, and if you obtain one with stripes of copper like this, you can cut a piece of this much size with the 4 holes on this side and 6 holes on this side. This piece is sufficient, and then you can solder all the components as per the circuit diagram onto the PCB. Now these two wires, these are the wires which will go to the battery, and because there is no holder available in the market for holding one single cell, you can use either this cell or AAA cell, which is slightly bigger like this one. Now in this circuit which I have already made, I am using this one AAA battery, which is bigger, which will last longer. So you can solder two washers, copper washers, brass washers, or terminals. Wire terminals are also available like this. You can use these, and then you can, this is the negative side of the battery, this is positive, and you can put these two here, and then you can use a tape to hold these, like I will show you. Leave some more tape. So this will hold your wires onto the battery, and You can check whether this circuit is working with an LED. Connect the anode of the LED to the positive wire and cathode to the negative side, and the LED lights up. So the circuit is working. Now, before fixing into the this uh, body of the CFL, you need to connect the switch, otherwise the circuit will be on all the time. So you can cut this wire from here, positive wire, in between, and connect both the ends to the switch. Solder these onto the switch like I have done here. In this one I'll show you. This is the battery, this is the whole circuit, transistor and complete circuit. Output I have connected to the wires which go on top, and this is the switch. So the positive wire which you will cut, connect both the ends to the switch with the solder. But be careful when you solder. These switches are very delicate, so don't heat for too long. And the best thing which I have found by experience is you scrape little bit, scrape the terminals of the switch with the knife carefully, then solder them. But do not put the soldering iron for too long, otherwise the switch will become faulty. So just push fit the switch, and you can with the PCB. In this piece which I am showing you, I have not used the PCB. I have connected all the components just one end to the other end. But the housing is big enough. You can hold this. This is looks neat and good. So you can put all the components there, and this output I have told you can cut this positive wire, connect both the ends to the switch, and then from the one wire from the switch, one negative wire from here, you connect to these two wires of the CFL. Now you have to, before you close this, you have to be careful which wire you connect, which is the positive terminal. You can mark here with the pen that one terminal will be positive, like this, for your guidance, because that information you will need when you um, connect your this USB female. USB female will have, if you cut it from a wire, one end is positive red wire and other is negative black wire. So you connect the positive red wire to the positive end. So you need to mark which end is going to your positive side of the battery through the switch. Okay, so after finishing, you will get this piece, finished piece like this, and USB cable which you fit here, you can fix it, hold it with a epoxy. I am using M seal, which is here easily available. You can use any other epoxy which is available, and fix it here, and then it is ready. Now with this one you can run either this flexible USB light which is used on the laptops. So if you connect it here, then it lights up. Usually it runs on 5 volt, but the beauty of this circuit is that you are running it at 1.5 volt battery. And you can also, this USB fan is also available these days from component shops or from Amazon and Flipkart. You can order online. So this fan, fix these blades on the top, and then put it here, and you can run the fan. You can, this is flexible, you can turn it and you can put it on your workbench while you are working or studying. You'll have cool air in summer. And the beauty is that you are using components from a discarded CFL and running your circuit from just single 1.5 volt battery. So when you show this to your friends, they will be surprised. Okay friends, I hope you like this video. If you have any comments, I will welcome your comments, good or bad, whatever they are. If you don't like, let me know. If you like, let me know. And if you have any questions on electronics concerning this video, I will gladly answer all your questions. Okay friends, I hope you like this video. Thank you for watching.